Right. No, that's all like searching for new applications, or
Okay.
the camera robots, or it's like a playground for technologies that we want to use in other more directly commercially applicable, like our real work, where companies that or companies that you've heard of are like, we're trying to do this
Yeah.
thing. Can you figure out how to make the robot do this thing? We're like, yeah, that
Yeah.
looks just like the camera robot. That looks just like the coffee robot. Or
Hmm.
we're using the same APIs because those are more like exercises and kind of fun things that we're playing with as demos, right? Demos or learning opportunities. But to get more specific about it, a lot of the stuff that we're interested in is it's more like it's really augmenting, or it's like hooking up with robots with newer software systems. So some of the stuff that we get most excited about is when we can really take over control of all the joints. Uh, Sometimes that's just spatially, like move to
Hmm.
this location, and sometimes maybe at a millisecond or two, but it's, we're almost sort of saying, okay, robot controller, just please do what we say exactly all the time, because we have our own software. There's other systems, there's AI systems that are making decisions on the fly, because a
Hmm.
lot of the traditional robotic systems, they have scripting, or they have legit code software in there, but it tends to have kind of like a push play and let it go kind of a feel to it, or like a kind
Hmm.
of PLC kind of feel to it, where it's like it's running routines that are really, really repetitive. And so a lot of those things where we're hooking into new systems for decision making, or for increasing the accuracy, or for being really adaptive all the time because the part is always different. Those are things that where a lot of new software and sensing technology can make robots do new things they
Hmm.
couldn't do before. So sometimes it's just dealing with variability, even if it's just dispensing. It's like, well, the part that comes out of the mold is squishy, and we scan it, and every time we change a path every time. Even that kind of a problem is not always that well served by existing dispense solutions. Or let's say you had a dispensing system that has a handful of servo axes because there's a few fancy pumps and there's some mixing. Like, you have this other complicated system that needs to coordinate really tightly with the six
Hmm.
axis robot. There are ways to do that out of the box from the robot suppliers, like, don't get me wrong, but there's also a limit, or there's also, you can take it further. um, I think a common example that we see that I could talk about generally is like I mentioned in aerospace, where
Hmm.
some of the most interesting applications were in carbon fiber layup. So they're taking little strips, or sometimes big strips, but little strips, maybe 16, 30 rows of little strips of tape,
Hmm.
and they're flying that actuator across the surface, and they're cutting those edges of that tape at 2 meters a second. They have to lay down the edge within like a fraction of a millimeter. So if you
Hmm.
do the math, you do the motion control math, you're like, well, we have 30 axes that need to be 30 servo axes, and
Hmm.
these triggers that need to happen with sub millisecond timing along the path. You cannot do that with a regular robot controller.
No.
Are you using
And
vision in
so,
that
yeah.
mix as well? Are you like detecting those edges using vision, or is that position
No,
based?
sometimes usually it's pre-planned, but it's just
Hmm.
exactly at that location, because they're laying stuff on top of each other and all the edges need to be aligned, or they really care about it. Like if they're, a millisecond or two is a millimeter, right? Like on those machines, and that's not as accurate as they need to be. So those are examples. Or yeah, even just taking it and measuring it, or doing live compensations, scanning the part and then redoing. These are all places where there's a lot of flexibility, where new software tools or better coordination or better timing means that, well, yeah, you can take this, $50 or $100,000 robot and make it do something that otherwise might be like $1 million gantry to build to do
Hmm.
that. And so in places where that's, and that opens up to places that makes it cheaper to build carbon fiber parts and makes it better. Now more
Hmm.
airplane parts are made out of carbon fiber. It's just, those are the kind of things that we're helping people to innovate on. At least when we're going high end, or we're going in terms of like really expanding what a robot can do by like usually software or other systems, or other coordinating with other motion control systems. That's where there can be a lot of new things happening.